outcomes. Okay, how to collect the all outcomes combined events. This is an example. Two coins are tossed together, or a coin is tossed. So we have two method here. One is the two-way table and another is tree diagram. So first of all, we are going to discuss two-way table. Okay, this is two-way table. Correct. So in two-way table, see how you make two-way table. You tossed. If you toss a coin, you get head or tail. Here also, head. There are two possibilities. Right? When we toss a coin, so there are two possibilities. Correct. So suppose first coin gives head and second also gives head. So at H to H, this outcome is H to H, then H to T, right? Then T to H, and then T to. So there are four possibilities. There are four outcomes. Understanding? There are four outcomes. When two coins are tossed, so there are four outcomes. Okay. So for example, here we have probability. We have to find out uh, probability of exactly two heads. Suppose you have to find out probability of exactly two heads, right? So how can you find out its probability? You know, there is only one favorable outcome, okay, in which we are getting exactly two heads. So there is only one favorable outcomes out of 1, 2, 3, 4, 4, right? Suppose we have to find out probability of at least one head, at least one head, okay, at least one head. So there are three outcomes in which at least one head is coming. So 1, 2, 3, 3. There are three outcomes in which head is coming. At least one head. Okay. So there are three favorable outcomes and over total number of outcomes. Okay. Suppose you have to find out the probability of exactly two tails. Exactly two tails. Right. Then you have how many favorable outcomes? Two favorable outcomes. Then this is 1 over 4. Understanding? Am I clear, WD? Now this is a two-way table for when two fair dice are rolled. So see how to collect the outcomes. So first 1 to 1, right? 1, 1. Okay, this is first outcome, or right. It's not necessary to write the bracket. Even you can write it's 1, 2, 1, 3. This is 1 and 4, 1 and 5, 1 and 6. And then this is 2, 1. This is 2, 2. This is
2,
2.
3
Yes, 2, 4, 2, 5.
until 2, 6.
Yes.
And do the same with the other for 3,
Yeah.
4,
Yes.
5, and 6.
Yeah. Yeah. Same. 3, 1, 3, 2, 3, 3, 3, 4,
3, 4, 3,
3,
5,
5, 3,
and
6,
3, 6.
4, 1,
4,
4,
2,
2, 4,
4,
3,
3, 4,
4,
4,
4, 4,
4,
5,
5, and 4,
4,
6.
6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. Okay. If you count, total outcomes will be 36.
36.
Yes, total number of outcomes will be
36.
36. Right.
Yes.
Now, what type of question you may have? You may have a question, this type of question from the table. For example, probability of right, same numbers coming, probability of in the pair coming same numbers. same numbers. Okay. In the pair coming the same numbers. So same numbers means you can see what we are looking for, the same number. So 1 is same number, 2 is the same number, 3 is 4, 5, and 6. So we are getting this one. This we are getting same number. How many times? 6 times.
So 1
How-
out of 6.
Yes, right, absolutely. 6 out of 36. Okay, that will be 1/6. Right. Suppose probability sum of the numbers, sum of two numbers means 2. Okay, obviously there will number in there, so 2. Sum of the numbers or sum of two numbers is less than 10. Is less than 10. Okay, we have such event that we have to pick up two numbers and whose sum is less than 10. So what you will do, see this, we will look for these one. So this one, yes, we all see this one. If you see all this, that sum is 7. Okay, here this one 3, here this one, this, here this also all. I think this also all, right? Yes, this, not this, and this one, this. Okay, so we have these outcomes when sum of two number is less than 10. Okay, so you can count again. I did it carefully. Okay, so 6 and 6, 12, 18, and 18 and 5, 23, 23 and 4, 27 and 30. Yes, 30, right? We have 36 outcomes, 30 over 36. So 6 5s and 6 6. So this is the probability of this event is 5/6. Clear this one?
Sir, do we have to draw the whole table, sir?
It's better to
Yes.
draw the whole table for your better knowledge.
Oh, okay.
Even you can, it's not necessary to show the whole table. You can draw the only those outcomes which are required. But this is my personal suggestion. Draw the whole table. It will help you to collect the all outcomes. Okay, and even to see the things in details. Right. For part A, we have to make a table that we have made here. And what is the probability that both dice show the same number? Right, probability of both dice show the same number. Okay, so we are looking for the same numbers. So both dice show the same number. This, and this. Okay, and how many? 1, 2, 3, 4. 4, therefore, and total outcomes are how many total outcomes? 4 times 4 is 16, right? 4, 8, 12, and 6. Total outcomes are, total number of outcomes are 16. So this is 1/4. Okay. Now probability of, for example, we have, what is the probability that the number on the dice is double the number on the other, right? Number, here number, and twice the number here, right? Look here, what is it? The number on one dice is double the number on other sides. Okay, so let's number here and it's twice. So first of all, this one, 1 and 2, 2 is double of this one, then 2 and 4, right? Then 2 and 4. Is there any other pair? I don't think. One,
With the what? Oh,
right? Suppose x here, suppose x here, it should be 2x, twice of this. So we have only two such outcomes. So 2/16, that is 1/8. You guys, probability.
Wait, sir. For the one dice on one dice is double than the other. Cannot 2 and 1, sir. Only 1 and 2.
2 and 1. Yeah, your question is right. But according to this one, yes, we have to write yes 1 and 2. Why? If we read the statement that the number on one side is double the other side. Okay.
Yeah.
First we have 1 and 2. Number one dice is double the others. Understanding? Relation.
Ah.
Relation this way. What one side, one dice, one number on one dice, number on one dice this way, number on one dice, right, is double, right, is double on other side, right? So that's why one side this one, so it's double. That's why this way relation is this arrow. Look the arrow. This way we have to
Okay.
reverse. Not he is not seeing the reverse. So in this case, right, and D, what is the probability that sum of both numbers is prime number? Okay, so prime number, sum of number is prime. Sum of number is prime. Okay, so then you will have to check which are giving prime number. This one, like 1 plus 1, 2 prime number, yes. Plus 3 prime, yes. This is no, yes, this is. Yes, this is, yes, this is. Then 3,
3, 4, yes, sir. 3, 4, yeah.
3, 4, yes. Then 4 and 5, 4 and 3, yes. So count 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? There are 9 such outcomes. 9. Is it okay? Let's see study now tree diagram. They will understanding. Things not clear. Will take more clear. Okay, so let's move to the next. What is tree diagram? Tree. Okay, look. Tree diagram. Okay, it's very interesting. Tree diagram. In tree diagram, suppose, for example, a coin is tossed, right? A coin is tossed. And see, look how I will show this through the tree diagram. A coin is tossed. So what are the outcomes? Suppose this is a toss. The outcomes will be head or tail, right? If a coin is tossed, what will the outcomes? Head or tail? Now what I'm telling you, two coins are tossed. two coins are tossed, or a coin tossed twice. Two coins are tossed. So when I'm saying two coins are tossed, so it means what? If first, right, if first coin gives head, right, if two coins are tossed, means if first coin gives head, and what is the possibility for the second coin? Second coin may give you head or tail, right?
Yeah.
For example, if first coin gives you a tail, so second coin can give you head or tail, right? Understood, guys? This one, this understanding this one, everybody? Two coins are tossed,
Yeah.
or coins it tossed twice, or you can say, or a coin is tossed twice. A coin is tossed. So suppose in first toss we get head, so in second we can get head or tail. Or if we get tail in the first, in second we can get head and tail. Okay, so now, for example, three coins are tossed. Three coins are tossed. Three coins are tossed. Right? Or a coin, or a coin is tossed thrice. Is tossed thrice. Okay. So what is the possibility? So now we start from the second, because we have already done up to second. So if in second this head, so it may be head or tail. Similarly here, if tail, head or tail. If this, head or tail. If this, result is head and tail. Clear? This way, okay. If I count this way, H, okay, from this gives me H, triple H, okay, H, triple H. Then T, okay, T. This gives me head and tail. If this HTH, from this one, HTH, okay, HTH, okay, from this TTH or HTT, HTT, from this HST or TH, okay, from this THT or THT, yeah, both way same. From this HTT or TTH, and from this triple T, okay. So there are how many outcomes? 1, 2, 3, 4, 5, 6, 7, 8. Total outcomes, total number of outcomes, total number of outcomes was to 8. Okay, total number of 8 count. Okay, 8. Now look here, probability we have to find out. Okay, probability of this one. Okay, now suppose I ask you, this time I'm not showing the probability here, but right, you know the things you are collecting this one. If I ask you what is the probability of exactly 3 heads, okay? If I ask exactly 3 heads, how many favorable outcomes you have? There is only one event, exactly 3 heads. There is only one head, right? There is only one head. So what you will write? What will you answer? Your answer will be 1/8, right? But if I write probability of at least one head, at least one head. So what will be your answer? You'll write all those elements which are giving you head, right? Wherever you find out head, this is head, this event, this event, this event, this event, okay, and this event, exactly one head. Sorry, at least one head. Okay. So then what you will write? How many? 1, 2, 3, 4, 5, 6, 7. There are 7 out. Okay. If I ask you, what is the probability of exactly 3 tails? So what will you answer? You know, there is only one event out of 8. Okay. This is called the tree diagram. In tree diagram, this is one of the way to find out. Okay, to find out. And here I will mark the probability of each one. Okay, after this one, suppose what is the probability? 1/2. This is also 1/2. This is also 1/2. This is 1/2. Here 1/2. Each one, you know, here 1/2. Right? Here probability 1/2, 1/2. This 1/2. You can write the probability of each branch. And one more interesting thing, if you don't want to go this way, you can write this way also. Probability of 3h. So if you look at probability of 3h, look this way also. This way. Okay. So I can write here. I can write, if I do not write this way, another way I can write this is 1/2 from here, 1/2 from here, and 1/2 from here. That is 1/8. Answer will be same. Either you multiply this way or you just look out the these outcomes, favorable outcomes, that is 1, and then total outcomes. Okay.